Since an equation is made up of two algebraic expressions, the distributive property, as we've already learned it, can apply to equations, specifically multi-step equations. The distributive property is a method of simplifying an algebraic expression by distributing a value to each term in a set of parentheses through multiplication before combining like terms. The basic example is A times B plus C. Think of it as trick-or-treating. That A needs to give candy to all of the trick-or-treaters. So it's going to be multiplied by B and multiplied by C. A times B gives me AB. A times C gives me AC. This is the general form of the distributive property. In just an algebraic expression, it looks like this. You're going to distribute the value outside of the parentheses by each term inside the parentheses. 3 times 2 is 6. 3 times 4x is 12x. I need to remember to rewrite the algebraic expression, including all evaluated and non-evaluated terms. I did not evaluate or use 2x in any calculation, so it comes straight down. Now I combine like terms if necessary. This is how we simplify algebraic expressions. So I'm going to categorize all my terms. I see 12x and 2x. I want to start with my variables, so that gives me 14x plus 6. Let's try simplifying another algebraic expression that requires the distributive property. So I see negative 2 times 4x minus 5. I need to start with my distributive property. So I'm distributing negative 2 times positive 4x. That's negative 8x. Negative 2 times negative 5. Remember, if the value's negative, you're distributing a negative to both terms, despite the terms inside the parentheses sign. Negative 2 times negative 5 is positive 10. Bring down everything that did not get evaluated. That positive 2x at the end and at the beginning comes straight down. Now I can categorize my like terms. I see 2x, negative 8x, and positive 2x. 2 plus negative 8 is negative 6. Negative 6 plus 2 gives me negative 4x. So I'm combining just the coefficients. So negative 4x, constant of 10 does not combine with anything. There's my answer, negative 4x plus 10. On your own, try simplifying the next algebraic expression that requires you to distribute using the distributive property and then combine like terms. Distributing in equations is no different than if you distribute in an algebraic expression. You distribute on the left, you distribute on the right if you need to, combine like terms on the left, right, get all the variables together, and solve. This is just one more step that you need to follow before turning the equation into something that you can solve using your 1 or 2-step equation rules. You begin by distributing. You can either distribute on one side, or if there's distribution on both sides, you'll need to do it to both sides of the equation. In this case, I'm going to take 3 times 2x to get 6x, 3 times 9 to get 27, 6 is by itself. Combine like terms if you can. I have 6x and 27. They're unlike terms, so it's already simplified. All of my variables are already on one side, so I don't need to move any variables right now. Decide what type of equation you have after you've simplified the equation. I have 6x plus 27 equals 6. My variables being multiplied and then added. So I have 2 steps. This is a 2-step equation. So I'm going to take care of my my operations according to the order of operations. So it's being multiplied by 6 and then added 27. So I'm going to subtract 27 and then divide by 6. So if I subtract 27 from both sides, 27 minus 27 gives me just 6x. 6 minus 27 gives me negative 21. I'm going to divide both sides by 6 to get my x by itself. Negative 21 divided by 6 gives me negative 3.5. Remember, negatives and decimal answers are okay. Let's try a problem together. So first I'm going to distribute. I only have distribution on the right side, so I'm going to distribute negative 3. Negative 3 times 4x gives me negative 12x. Negative 3 times positive 2 gives me negative 6. I'm going to bring everything else down. Plus x, the 5 equals 9. I want to combine like terms on both sides. 9 is already by itself on the left, so I'm going to combine just on the right. I have constants, I have sets of x. Negative 12 plus 1x gives me negative 11x. Negative 6 plus positive 5 gives me negative 1. This is a two-step equation. My variables being multiplied by negative 1, and then we're subtracting being multiplied by negative 11, and we're subtracting 1. So, in order, I'm multiplying by negative 11, subtracting 1. Inverted, I'm adding 1 and dividing by negative 11. So I'm going to add 1 to both sides. Negative 1 plus 1 equals 0. 9 plus 1 equals 10. Divide both sides by negative 11. Negative 11 divided by negative 11 equals 1. 10 divided by negative 11 equals 0.91. Negative 0.91. If I substitute that value back into my equation, either in the simplified or unsimplified version, I should get a true statement. On your own, try the next two problems. Remember to distribute, combine like terms if need be, get all variables on one side of the equation, and then solve. The only time you need to use inverse operations to combine like terms is if you're moving variables from one side of the equation to the other in order to get all variables on one side before solving.